y equals 1, 1 squared being 1. And the question we want to find out is, what is the slope at this point? So how steep is that line? It's obviously positive, it's going uphill, but how steep is it? Is it going up 1 to 1 at that point, or 2 to 1? How do we know? So what we need to be able to do is we need to be able to change x squared into what's called the derivative of that function. So we need to differentiate the function to get the derivative. And we need to have some way of writing that we've done this. So it's not going to be y anymore, it's now going to be the derivative of y. So we're going to find the derivative of y. And we've got a couple of different ways of writing this. We can either write it as y dash is one way, so we dash means I've differentiated. And the other way we do it is what's called dy by dx. So the way of speaking here, dy by dx. And again, this means we've differentiated y, and the advantage of this one is it gives us a bit more information. It tells us that x was the variable. And at this level, that's always going to be kind of obvious, but when you go on and do things that have got more than one variable that might change, then this notation is very, very useful. So this one will work at this level, but this one gives you more scope to expand in the future. So I'll use both, and you need to be familiar with both. Okay, so if we differentiate x squared, we get 2x. Okay, at the moment that's a little bit of magic, where that came from, why that is 2x, but that's the answer, and I'll explain that to you in a second. But what that means is that when x equals 1, the slope, dy by dx, is equal to 2 lots of 1, which is 2. So at this point here, the slope is equal to 2. If we carry on a bit further, so if we take another point, say if we take x equals 2, my diagram's not really drawn to scale here, you can see that up here, it's clearly got a lot steeper. The parabola gets steeper as it goes on. So by the time we're up here, when x equals 2, the derivative is 2 lots of the new value of x, which is 4. So at this point, the slope is 4. And this technique is even smart enough to get the ones that are going downhill. So if we look on this side, let's take x as being negative 1.5, and we say, what's the slope at that point? Well, clearly it's a negative slope. So when x equals negative 1.5, dy by dx is 2 lots of negative 1.5 is negative 3. So it gives us the sign as negative because it's going downhill, and it gives us a size of the thing as well. And then there's a fun that I alluded to last time, which is that this point right at the bottom is where the slope should equal 0. So this is the point where the slope equals 0, and as you can see, to make that true, x has to be 0. So in this particular case, the derivative is equal to 0 at the point x equals 0, which makes sense in the parabola. Okay, so the question is, how did I do my magic? How did I change x squared into 2x? What was going on from there to there? And there is a way of working it out called first principles, which I'm not going to show you because it takes a long time. But at this level, we have a formula sheet that does the magic for us. So on Moodle, there's a formula sheet, and we'll insert a slide into the video with the formula sheet. And basically it has a huge, great table on it. And on the table, it's got, at the top, it says y equals some function, and on the other side, it says the derivative, or it's got that other notation, the dash notation. So it tells you each thing, what the function is, and what it differentiates to. And on that, it's got one that says x to the power of n, and the derivative is nx n minus 1. Okay? So in this case, we had x power of 2, so n was 2, so the answer is 2x, 2 minus 1 is 1, power of 1. So x squared is changed into 2x to the power of 1, so really there's a wee 1 on there. But powers of 1 don't change anything, so we just don't bother writing it, we leave it off. Okay, so if you've got an x to any power, you can differentiate it by doing this process. So for example, if we had y equals x to the power of 4, then dy by dx, okay, so the 4 comes down the front, x, and the power reduces by 1, so 4 minus 1 is 3. Okay? And there's nothing magic about whole numbers, so we could have something like y equals x to the power of a half. And when we differentiate that, the half comes down the front, x, and we take 1 off the power. So a half minus 1 is negative a half. There's nothing magical about negative numbers. Same thing, dy by dx, number down the front, take 1 away from that, negative 4. And this gives us an ability to differentiate a whole lot of different things.